Hello, my dear ones. This is Amit welcoming you all to the new video of your own academic channel, Vihan Classes. Here we are going to discuss few more problem of exercise 6.3 and we'll begin with question number 4 and we'll try to take few more question of the same exercise. So tune in and like and share as much as you can and starting with the question, here the question states that as it is written in the question, in the given figure is there in the question itself, QR over QS. So you must be seeing QR and QS are the two portions of the base of this entire figure, and QT over PR. QT is the this portion and PR is this portion. Now that is all right. Angle 1 is equal to angle 2. Here this angle 1 and angle 2 has been given as equal to each other, and we'll see how this information is helpful for us. This is the cracking point of this question. Show that angle PQS and TQR. I hope you might be able to see the two triangles PQS and TQR are similar to each other. So as the question states that angle 1 is equal to angle 2, let's see what does it mean. Let's try to have a copy of this triangle PQR from where I have taken angle 1 and angle 2 together. So here I'm dragging. I am taking one copy of this PQR away from this figure and showing angle 1 is equal to angle 2. You might see angle 2 is the angle that is formed at R and angle 1 is that one formed at Q. And on basis of this information, as these two angles are equal to each other, we must be knowing from the basic geometry जो हमने earlier classes में पढ़ा हुआ है, if the base angle of a triangle are equal to each other, they must be an isosceles. The corresponding opposite sides of the two angles must be equal to each other. So if it is given in the question as angle 1 equals angle 2, so on this basis for angle PQR we can say in triangle PQR we can say PQ is equal to PR. Is that clear? Angle 1 is equal to angle 2 indirectly gives us this information. And what else thereafter? One more information has been given. QR over QS. Let's try to write this once again. QR over QS is equal to QT over PR. अगर ये दोनों रेशियो इक्वल हैं, हम इस फिगर में चल के देखते हैं. QR को हम समझ सकते हैं यहां से यहां द होल एंड QS इज द पार्ट. इज दैट ऑल राइट? और फिर दूसरी तरफ QT ओवर PR. QT को हम देखते हैं तो ये होल होता है एंड देन PR इज नॉट पार्ट ऑफ दिस लाइन. दैट इज द इश्यू. QT ओवर PR. लेकिन जैसे ही हमने इस इंफॉर्मेशन में देखा कि PQ और PR तो इक्वल हैं, तो we can rewrite this statement as QR over QS is equal to QT. Instead of PR, we are replacing this value by PQ. As we know, PQ is equal to PR. And what after this? You try to look for this part of information in this line. Let me try to remove this. See in this figure, entire figure, I can now see it as QR the whole over QS is equal to QT the whole over PQ. That is the part QT over PQ. So whole over part, whole over part. That reminds me something. Let me drag this figure away and rotate it a bit and making this as QR over QS. From top to bottom you can see here QR the whole over QS is equal to QT over PQ, the part. And this reminds me something that if the corresponding ratios of part of triangle are equal, then we may say this line PS must be parallel to TR. This suggests this suggests PS must be parallel to TR, that is from converse of BPT, sending this figure to its original place and in original form as well. So we have proved PS is parallel to TR and dragging this figure to its original place. And once PS is parallel to TR, that suggests us something. PQS. Let's see this question. PQS, this triangle. If these two lines are parallel, then what you can say, this angle is equal to this. So writing in formal, in statement, mathematical statement, angle QPS is equal to angle QTR, and thereafter this angle QSP is equal to angle QRT, and angle Q is common. If we compare these angles in triangle QPS and angle QPR, all three angles of them are equal, then we can easily say triangle PQS is similar to triangle PQR. Here I have written name in some different manner, but correspondence for angle P, it is angle T. For angle S, it is angle R. And for angle Q, it is angle Q only. So this is proved. The two triangles are similar to each other by AAA criterion. I hope this is clear. You keep on liking and sharing, and if you have some doubts, you can type into the comment box. I will try to reply that. And moving on to the next question. Here the question says something, but the figure has not been associated. Any figure has not been associated in this question. So let's draw first a triangle PQR. This question is talking about a triangle PQR. So let's draw a triangle PQR, P, Q, and R. PR and QR, having on PR it is S. The scenario is like this. S is over PR, point S, and this is point T over QR, such that angle P is equal to RTS. Let's see, angle P is equal to RTS. These two angles are equal to each other, which is shown here in this figure. So now try to take two triangles which we are supposed to prove similar to each other. Take them separately. This is the whole triangle PQR, and this is the part of it, a small triangle STR. Writing its name PQR, and this is STR. What has been given? This angle at P is equal to this angle at T, as given in the question, you can see. And thereafter, we can consider by common sense the angle formed at R are common in both of them, isn't it? R is the common vertex of both the triangles. So we can call angle P is equal to angle RTS that has been given, and angle R, that is PRQ is equal to angle SRT, that is common. And if two angles are equal, that is sufficient to call any two triangles similar to each other. So calling a triangle RPQ similar to triangle R is the common, and in place of angle P, we will take the angle T. So vertex T will be here, and Q will be replaced by S. So that is criterion. We have proved these two triangles similar to each other.